Hey everyone, I'm David O'Leary,
I'm Sarah Benson.
and today we are presenting ways to create alcohol-free beer and its relation to Henry's solubility constant. So here, our basic need here is that people want an alternative way of drinking beer in social settings that they don't need to consume actual alcohol for less calories and for maybe pregnant women who want to drink it. And it's very difficult here because ethanol is separated during stripping, but the main issue is that it is very difficult to isolate ethanol while also keeping the flavor inside the beer.
So moving on to the study that we're examining, the purpose was to look at the effect of ethanol concentration on the three major flavor components to beer. And the relationships to calculate these correlations are mathematical in foundation. So we're focusing on Henry's law constant and the two suffix modulus equation.
Yeah, so for important equations here, we start with Henry's law constant. So typically in our calculations of Henry fugacity in the liquid phase, Henry's law constant is used when we have very small mole fractions of a certain species. And for here, the flavor mole fractions are very small, and we are going to use Henry's law for those. And our Henry's law constant can be calculated as shown here with the concentration of the liquid over the concentration of the gas and our expanded definition here. So for the Margulis equation, a mathematician named Wall used a power series expansion to create a general expression for Gibbs free energy, excess Gibbs free energy, which methodology is beyond the scope of the course. And in class, we mainly use two suffix and three suffix Margulis equations for applications for two component systems. In here, we are going to be using three component systems, but a two suffix Margulis equation, as our three components are water, flavor, and ethanol. And the beta values are adjustable parameters as shown in the equation below.
So the way that the Henry solubility constant and the gamma values are related is through the fugacity. So we see the expressions as follows, where the fugacity of the liquid phase is equal to the mole fraction, gamma, and reference fugacity and the pointing factor. And then we see that in species 2, the Henry's constant is used because it is at an infinite dilution and is related using a symmetric convention as shown by equations 8 and 9. And then to relate this, the values are compared and combined to create equation 10. And then the two assumptions are that the limit condition means the concentration goes to 0, and that can be manipulated in terms of the fugacity and the mole fraction in order to get the expression. So based on the results, we see that the value A13 plays a large role in contributing to the flavor profile, and at lower concentrations of ethanol, the influence is less. These are our citations. Thank you.
Thank you and cheers.